Do you remember this formula? A equals, let's not use blue on blue. That's A equals principal times 1 plus interest rate over the compounding factor to the compounding factor times t years. Remember that from Algebra 2? It's a compound interest formula. It's an example of an exponential function. Yeah, I know there's a lot of parts to it. But no, you don't need to memorize that. I'm just asking if you remember it. No, you don't remember it. Let me spell you. Gotta tell you a story. About this guy named Leonard Euler. I know it looks like Euler, but his name's Leonard Euler. Super cool dude, pretty nerdy. I mean, really nerdy. So he said, what if I take this compound interest formula and I invest $1? Right? I can see that right here. There's a 1 right there. I invest $1 at an interest rate of 100%. You know, everything we hope and dream. 100% interest. And he did it for 1 year. What he said to himself is, I wonder what happens if you start changing the compounding factor. Start small and get big. So he did that, right? This is the super nerdy part of the story. He's plugging in numbers, right? And what he noticed was it's increasing. But the rate at which it increases starts to slow down. And it was getting closer and closer to a particular value as he noticed over time, right? And so he found that it was getting closer and closer to a particular line. And it's approximately 2.718, but that's a really, really long, irrational number, which never stops and never repeats. So they said, hey, why don't we just name this after the guy? So he got a number named after him. That's like the ultimate thing for mathematicians, to get a number named after you. So they named it E after his name. True story, folks. Can't make this stuff up. I mean, I embellish it a lot, but I don't make it up. So, all this time, so what do we call those lines? Where something is getting closer and closer but never touching? He found a horizontal asymptote is what he found, okay, to this particular function. As x goes to infinity, he found that this thing got closer and closer to that 2.718 blah, 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 blah number. Is 2.718 greater than 1? Is 2.718 greater than 1? Yes. Therefore, this is exponential what? Growth, right? Because E is greater than 1. Now, SAT and ACT always try to trick you with this. What number could we put in here for K? What kind of number could we put in here for K, which would change that and not make it exponential growth anymore? Decimal? Depends on what decimal it was. What number would guarantee that we would definitely? 0, e to the 0, that would be 1. No, that wouldn't give me. That wouldn't change it to decay. It would get rid of the growth part, but it would not change it to decay. What kind of number? Although you are getting 1 though. negative numbers? Now, if this is a negative number, remember from the algebra when you took something to a negative exponent, what does that do to the base? Watch my hand. Flips it over, right? Now, 1 divided by e, that's 1 over 2.718. Is that number smaller than 1? Yeah, it is. They love to do that on ACT and SAT questions. Suddenly you have a negative exponent, and that negative exponent is taking the base and flipping it over. You thought it was growth, but then according to what they make a change in the problem and they change it to decay. So it's only growth if this k is positive, right? If that k is negative, then we've changed it to exponential decay. You know, there's the basic looking picture of an exponential growth function. You should be able to look at that and tell me what domain and range are, right? Basic stuff about the function. It is a continuous function. Why do they use the word increasing? It says it's increasing for all x. Where does that word increasing or decreasing come from? We always have to move through the graph from where to where. Thank you very much, sir. From left to right through the graph. And so that's where that term increasing is coming from. There's definitely no symmetry. It's not an even function. It's not an odd function. It is bounded below, but not above. No local extrema. You know, one of my favorite extra credit questions on a test, I did this several years. I haven't done it in a while. And since I'm giving you the answer, it probably wouldn't be a good idea for an extra credit. Oh, look at you. Look at you. You were going to write it down until I said no? So if I ask you what's the lowest value in the range, what's the lowest value in the range of this graph? What do you think? What's the lowest value in the range? It doesn't equal 0, right? Because that's a horizontal asymptote in this graph. So what's the lowest value in the range? Okay, so I got to vote for, what was it, 5 or 6 zeros and then a 1? 6 zeros and a 1. 0.00 gave me 6 zeros and a 1. All I have to do is throw on a 7 0, and I got something lower than he had. So try again. That's right. The extra credit answer was does not exist. There is no lowest value in the range of this. You can't choose 0 and then don't say, oh, whatever number is just above 0. Okay? That doesn't work. Because no matter what number you pick, there's always something smaller than that. I know, it's a cruel world. Okay? But it was meant to get kids to think. I haven't done that in a while. Now, what is the limit as x goes to negative infinity? What is the limit of that function as x goes to negative infinity? That is 0, right? What's the limit as x goes to positive infinity? It goes to positive infinity. So on the one side, you see the horizontal asymptote, and on the other side, you do not. Now, that didn't happen with rational functions. With rational functions, both sides went to the same horizontal asymptote, which is why I never made you find both. I said as long as we went to the positive infinity, we would be good to go. Now, I did mention in class you'd actually technically need to do both, but we weren't going to worry about it. That only applied to the rational functions. This would have to do both, but folks, it's not going to get tricky, folks, at all. These things are going to start out at 0. What if I shift the whole graph up 5 units? Where do you think it'll be? If I take this whole graph and move it up 5 units, where do you think the horizontal asymptote will be? So Nobody knows if I push this thing up 5 units where the horizontal asymptote will be. How about y equals 5? It's not going to be that hard, folks. What if I move it over to the left? That doesn't change the horizontal asymptote at all. I don't care how far you move it. The only kind of change that would affect it would be vertical shifting. Stretching won't do anything to that at all. Okay, so let's look at these examples. We probably need to think about fireproof form. You're starting off with y equals e to the x. Now, if you need an example of fireproof form for this particular function, you know the whole y minus k over b equals e to the x minus h, that's a really bad h, all over a. Now, obviously, these examples that we're doing only have about one change in them, so it's not going to be terribly difficult. But do you remember that this is a 1x in the fireproof form? And so if you have a 2x, what are you going to be multiplying it by to change it to a 1x? 1/2, right? The reciprocal. Whatever you do to the top, you must also do to the bottom. So on this particular example, this would be e to the x over 1/2. So this and this are the same. All we did was try to figure out what was going on to the x's. What do you think is going on to the x's? Okay, take about 20 seconds. Talk to your neighbor and admire my neighbor. And see what you think. See what's on there? Yeah. The daughter's right where to put it underneath. They delivered this yesterday, so I could cover it. I love it, man. Yes, I never used it before.
Yeah.
Let's throw a hole through the side here. Go up. Talk to me about that cool idea you had. I really would like to know because I was thinking about that. Okay, tell me what's going on. Yeah, horizontal shrink. Yes, that is a horizontal shrink of 1/2. Since the number was less than 1, I knew it was a shrink, and it was on the x side, so I knew it was horizontal. All right, similar idea on the next one. Whoops. What are you going to do with that negative x over 1 so that we can get it so that it's positive x over something? You can multiply by negative 1. Now, I know this, folks, I know this is a boring thing to do. So y equals e to the x over negative 1. Okay, talk to your neighbors, make a conclusion on what that kind of change is doing. Okay, what'd you decide? I've got to vote for reflection over the y-axis. Do you think that's true? You're changing the x. It's definitely a reflection because of that negative. Now, if you are unsure what's going on, take a random coordinate in quadrant 1. This is what I do with you guys. And multiply the x by negative 1. Which quadrant does it jump to? When you multiply the x by negative 1, which quadrant do you move to? Third would be negative x, negative y. So that would require you to multiply both x and y. Fourth would not change the x, but it would definitely change the y. It is quadrant 2, negative x, positive y. So we did have a reflection across. Yes, you can be proud. That was a good moment. Okay, I liked it. Reflection across the y-axis. Now, wait a sec. Didn't we just talk about something a few minutes ago? I'll come back to this picture in a minute. But didn't we just talk about this? And didn't you just say to me something like, well, if this number is a negative number, what does that do to the base? It flips it, right? And we said that number would be smaller than 1. Okay, so let's think through this process. If you had basic exponential growth, y equals e to the x, and you reflect it across the y-axis, wouldn't it look kind of like this? Which reminds me of exponential decay. Okay, that idea should be matching in your mind. That 1 over that is causing it to become decay, very similar to the idea of reflecting across the y-axis. Okay? Last one. What do you do to get this in fireproof form? Divide both sides by 3, yes. So describe the change. Obviously, it's on the vertical side. Vertical stretch by 3. What if we threw this in? Now what? I got to vote for right 1. Is that true? By adding that minus 1 up in the exponent? That is right 1. Okay. What if I put a plus 5 on the outside? Up 5. So we could do all kinds of different things with these. And ask you to switch them into their fireproof form so that you could analyze the different parts. And I know some of the things you can see without having to switch to fireproof form. I understand that. Sometimes you guys mix things up when you don't. But modeling San Jose's population. It says in this question, we are assuming the growth is exponential. What kind of function do you think we should be finding? Exponential, thank you very much. I heard it in a couple places. That's a good clue right there. Yes. You will need your calculator. We got list 1, we got list 2. I'm going to make a suggestion that we not use 2000 and 2007. I'm going to make a suggestion that we call this 0. And what do you want to call this? 7. It'll make your life easier. Please type it in. Stat, enter. Clear that stuff out, clear that stuff out. 0 and 7, okay. 898759. 39. Everybody got that? Should see what this is going on. Oh yeah, we'll close that out. Get the data entered in. I'll fire up my camera. Since somebody stole my good calculator, I'll have to use this one. Alright, now, any questions on getting my data entered in? Little stat enter. Got to my lists. Any questions on data entry issues? Okay. Stat calc. Which one of the things in this list would be useful to me? EXP. Is that where like you can see things in the future, or is that, I don't know. What is that EXP?
Experience.
I'm saying it wrong. I know it's ESP, but that was the dumb joke I was trying to make. So, exponential regression. Ask for it by name. And we want to use list 1 and list 2. For those of you with the old school calculators, you're doing L1, comma, L2. Those of you with the newer style have the menu, and you can just put list 1 and list 2 in there. Right above the 7, there's a button that actually has a comma on it. Yep. And we should get an equation. All of us should get the same equation. If we didn't, there's a data entry issue. Correlation coefficient turned on, that's under catalog, which is above the 0. And you need to click on diagnostic on, just in case that has gotten shut off for some strange reason. We should all have our really cool equation, and it's so y equals 898,700. How did I know this number was going to be in this spot? Because it's the initial value. Oh, ding, ding, ding. Well, that makes sense. Sorry, my X looks weird. I'm sure a lot of people will say that. Thank you. I appreciate it. All right, now. When will the population population of San Jose, California surpassed 1 million people. Where do I put the 1 million? Yes, good. A former period I was in today said X. Now let's just think about that, folks. If I put a 1 million in for X, what would that mean? 1 million years from now, what's the population of more than likely a non-existent city? I don't know. I'm just saying. I don't know. I mean, because once Thanos gets here, man, it's seriously. Okay, this whole model's gonna be upset as soon as Thanos gets around, man. You know. Yeah, we should do calculations on. Oh yeah. All right, now. So we've decided to put the 1 million over here. Now, how are we going to solve that? Yes, we're going to divide by 898,759. Then what? Several of you stare at the problem because you don't know what to do, even though we did it last year. This would be one of those problems you might find in the woods. You might have to use a chainsaw. We're getting warmer. Because there's logs involved in it. That's right. Okay? I thought I was giving you good enough clues there. You know, the woods, chainsaw. Okay. Now, I know at this point, you're all, freaking out. I hated logs. Okay. Well, hopefully, when we get to that portion of the chapter, it won't be as scary as you think. But we're not going to go back to logs right now. I want you to go to your y equals, and I want you to put that equation in for y1. And then I want you to go to y2 and put in 1 million. So we're going to actually do this graphically instead of with logs, which I know you like better anyway. Okay, now, we probably need to think about quadrant 1, and we need to make a window that makes sense. So obviously we're going to start with 0 years. What would be a good thing to try for the maximum number of years? 2 what? 20? Okay, we could try 20. That's not unreasonable because 7 was giving me close to 1 million, so it might be overkill to go to 20, but at least I would know that the picture had what I was looking for. Now, population 0, what should be the high on the population? It's got to be over 1 million. We do not want 1 million to be the top because that means it would barely be at the top edge. So let's go, that would be fine too. I'm going to go with 1.2 million. So go to your window. Okay, go to your window. So we got 0, we'll take 20, 0, and 1. Oh, why did I do that? I said 1.2 million. So, yeah, that looks good. Graphic. Okay. So we got the exponential function crawling along there. And do they meet on screen? Mine's kind of ugly looking. I mean, I think maybe I'll expand my y's a little bit, and so maybe I'll go to 2 million. I thought that would make it look a little better, but obviously not a whole lot. Maybe I should have changed my x's. It does look like they cross in there. You do need to have the intersection value on screen. If you don't have the intersection on screen, it's not going to look all that fantastic. Okay? So, what do we calculate? We want to calculate the intersection of these things. Is the first equation y equals 809? Yes. Hit the enter button. Is the second equation y equals 1,000,000? Yes. Hit the enter button. Do we need to guess? Now, remember, the guess feature is only useful if you have more than one intersection on the screen. We do not. But in order to use the guess, if you would like to use the guess, it's more than likely the best if you just push the cursor toward the intersection. You don't have to be exact. You just have to be going in that direction. Now, obviously, I don't need to guess at all on this particular question because there's only one intersection point on the whole doggone screen. If there were more than one, if you didn't use the guess, you would get rather frustrated because it would keep going to the same one every time and it would never give you the other one. So it looks like it's about 18 years. Now, 18 years past what? 18 years past what? 2000. So the answer to my question was 2018. Yes, I rounded. I understand. Yes. Okay. Okay. If you got any homework questions, I'd like to answer a couple of them before we're done today. So you hopefully worked on something last night. There's some setting that has been changed on that needs to be switched back. You know, if you don't have any games or any programs in there, you could just reset the calculator. That's easy. That's second memory 712. It's pretty quick. Okay, switching gears to homework questions. And let me get my other drawing tool ready. Yes, go. Number 10. Compute the exact value. Okay, so we got 8 times 4 to the negative 3 halves. No calculator. Alright, we can do this. That's the same thing as 8 times. How do I get rid of this negative? How about we flip it? Alright, that's what we taught you last year. Alright, now, how do I change that fractional exponent into something else? I even drew you a picture, and I said it wasn't a nuclear bomb, right? It was a tree, and there were roots underneath, right? a square root, don't we? So 1 over the square root of 4 to the third. Does anybody know? That is 64, right? So we have the square root of 64. If only I knew what the square root of 64 was. 8. So we have 8 times 1 over 8. Right? Sorry, it's kind of... What do we get? No, yes, we do get a 1, right? 8 times 1/8 would be 8 over 8, or 1. So just using some of our algebra skills to come up with that. Okay, what else? Give me another one. Yep. 19. Describe how to transform this thing right here. Okay, a little fireproof form. All right, so what should we do with the plus 4 first? Subtract it to the other side, so that's y minus 4 equals 3 times 0.5 to the x. What do we do to get rid of this thing? Divide it. So y minus 3. Okay, so describe to me the two things that have happened. Vertical stretch of 3 and up 4. Yep. Remember that the k is separate from the subtraction symbol. So that is definitely moving up 4. Now sketch the graph by hand. Okay. So if I need to sketch this thing, I'm moving the horizontal asymptote up 4 units. Okay. Now I wouldn't worry too much about the stretch of 3, but the basic idea. Now, do you know if this is exponential growth or decay? This would have to be decay, right? Because it's smaller than 1. So I would be expecting to have something like this drawn. And if you truthfully want the y-intercept, you can plug in an x value of 0